Hey guys, today we're going to be learning about the areas between two curves. So basically, what you're doing is when you have a graph, let's say like that, and you have another graph that's like that, you want to find the area in between, you want to find that shaded region there. And to do that, what you're going to have to do is take the integral from a to b, which is the limits of integration, which would be where the two graphs intersect of f of x minus g of x dx. And it's always going to be top minus bottom, or the top function minus the bottom function, or if it's in terms of y, it would have to be right minus left. Because you can't really, because you have to take this area and subtract it from the area here to get this area. It doesn't work the other way around. So let's do an example, such as, let us say square root of x. We got here, okay, nothing. F of x equals square root of x, and g of x equals x squared. Pretty simple functions, not hard to graph. So we're going to graph it here. Right, this is f of x here, and this is going to be your g of x, which is x squared, right? So we're trying to find the area right here. And so to do that, when you take area equals the integral from a to b of the upper function minus the lower function. So we can tell the upper function here is f of x, which is the square root of x. So we're going to say the integral of square root of x minus x squared dx. But you also need the limits of integration, and to find that, you have to set the equations equal to each other. So we'd make square root of x equals x squared. We get here, well, this is kind of a difficult example to find the limits of integration, because you can't really do that. But if you just graph it, and you can kind of, it's pretty obvious to see that they're going to intersect at the origin, which is 0, 0, and at positive 1, because if you input 1 into each graph, then you get 1. So if we had done it, it would have equal x to the fourth, and x to the fourth minus x equals 0, and then take our next, third minus 1 equals 0, and see here you can see that x equals 0, and x equals 1. Right? So we have here 0 to 1. And we got the area to equal, and now we have to find the integral of each one. So the area equals the integral of 1 to 0, area equals 2/3 x to the half power minus 1/3 x third power evaluated at 1, 0. And you can plug it in. So 2 times 1 to 2/3 power, or 3/2 power over 3 minus 1/3 to the 1/3 power. And if you input minus that with 0, but that turns out to be 0, you can just solve for this, and you end up getting 2/3 minus 1/3, which is equal to 1/3. And so basically, that is the area between square root of x and x squared. And but to make this a lot easier, you have to graph it to see what kind of area you're trying to find. And remember, to find the limits of integration, you have to set the equations equal to each other. Sometimes it's kind of hard to tell which is the upper function, which is the lower function. And remember, you can also do it from right to left, but if you graph it, it makes things visual and makes everything a lot easier. Well, thank you for watching, guys. That's how you do area between two curves.